Hey everyone, welcome to today's video. We'll be tackling the LeetCode min stack problem. The goal of this video isn't just to show you the solution, because you can find lots of resources online for that. Instead, it's to help you build better habits and develop a better mindset to solve any coding problem effectively. By the end of this video, I hope you will feel more confident about tackling similar challenges in the future. Right, so let's get started. We can assume you are working on the task in the company. Basically, you have the story, you need to deliver this story as soon as possible, or you can assume you are in the coding interview. So follow this agenda. Firstly, you need to read and understand the question. And then there are some hints, so you can come up with the hints from yourself. Or maybe your teammate can provide some hint to you, or from the interview if you are the candidate to do the interview at the moment. So once you have some hints, the next step you can probably have some ideas and approach to make it work first. And then we will have some follow-up question to optimize. So you can pause the video, read and understand the question first, or you can click the link from the description to read this question. Alright, so pause the video again. You can use 1 minute to explain your idea, or you can ask some questions. Assume you're working on the story, or you are in the interview at this moment. Okay, so next step, some hints. So some hints are coming from questions, basically. So first question, how do we keep tracking the minimum value? We can use an example. So let's say if we push -2, 0, 6, 3 into the stack. So this is ordering when we are doing the push. And then the minimum value are sorted by this, -2, 0, 3, 6. And then what's the next question you want to ask? Also, there's some hints, like whenever we're popping, remember to keep track of the minimum value. So the second question is, do we need an additional data structure to keep tracking this minimum value? And if we do, how can we retrieve the minimum value in constant time complexity of 1? So there are some data structure like stack, where the pop and pop, the pip and pop function can offer the of 1. And, obviously, a variable can offer that. The array can do the constant time complexity as well. So, like, we have those hints, we have these questions and answers in your mind. So I suppose you have some ideas. And whenever you have some ideas, try to use some basic examples, or some like example that provided by the story or the question provided from the interview. So the idea is to use an additional data structure, basically an additional stack. We call it min stack. Let's use some example to test. Basically, we can test the push function first. Let's push -1. And in this case, the min stack is to store the minimum value at the moment. So the min stack is empty, and then we push 0, 0, -1. That means we need to push the -1 into the min stack as well. Now let's keep pushing. So we push 0. So now 0 is greater than -1, right? So the question to ask yourself, what is current minimum value at the moment? It's -1, right? So in this case, we don't need to store the 0 in the min stack data structure. Let's keep pushing another element, -2. And -2 is the current minimum value at the moment, right? It's less than the top value from the min stack. So in this case, we need to keep pushing something into the min stack, which is -2. Let's keep pushing. So we push 6. So what is current, after we're pushing number 6, what is current minimum value at this moment? It's still -2, right? So do we need to update the min stack? We don't. We don't need to store number 6. Let's do another test to push number 3. Do we need to do anything to the min stack? We don't, because the current minimum value is still -2. Alright, let's do some testing to pop. So let's assume we're going to call the pop function twice, which means it will remove number 3 and 6. So after we do that, do we need to update the min stack? We don't, because we didn't store number 3 and 6. And now let's test another pop. So we remove -2. So -2 is gone. And now what is current minimum value? It's not -2, right? It's -1. So that means after we pop, we have to update the min stack. Meaning if whatever we pop is equal to the top value from the min stack, we need to remove from that value from the min stack as well. Meaning we're going to remove -2. Alright, so let's do another test. We keep popping. So we pop 0. In this case, do we need to do anything? No, we don't, because we didn't store 0. Okay, so last operation, keep popping. We remove -1. So in that case, we obviously need to remove the -1 from both data structure. All right. So that's pretty much, and let's show some code. Okay, right. So let's go through the code. As we discussed, we're gonna use 2 data structure. One is a stack, one is a minimum stack to keep tracking the minimum value. Constructor to initialize the 2 stacks. For the push function, so firstly, whatever the user is calling the push function is passing the value here, we're going to push into the stack. And then, as we showed in the previous slide, if the value is less than the top one from the min stack, we're going to push into the min stack. And for the pop function, some non-check, like whatever, whenever we call the pop function, we have to just go ahead to pop from the stack, and then we check, do we need to pop from the min stack? If the value we pop from the stack is equal to the current value from the min stack, which means the top value from the min stack, if it is, then we're going to update the min stack. So it's basically, as long as you virtualize the testing process from the example, the code is pretty simple. And then like the last 2 functions are very simple. So basically the top function is to just pick from the stack, and the get min function is basically to get the value from the top element from the min stack. Yep, that's pretty much. Okay, let's come back to the slide. So now we have the working solution. And some follow-up questions, like again, assume you are working on the story in your company, in your team, and also, or maybe you are in the interviewer to tackle this problem. You can get some follow-up questions, like to try to optimize your solution. So in this case, ask yourself, do we really need additional data structure to keep tracking the minimum value as we go? So basically, try to avoid using the additional stack. Okay, so for the follow-up question, I'm gonna just show the code from the video. You can pause the video to check. So basically, we're gonna replace the min stack with the variable. And as you can see, the push and pop function are a little bit different, but top and get min function are pretty similar. So pause the video, try to understand the solution, and if you still have any questions, feel free to leave any comments in this video. Alright, that's it for today's video. I hope it helped you to understand the question and the solution, but also give you insights into developing better problem solving habits. If you found this video helpful, don't forget to like subscribe and leave a comment. Let me know what you think or suggest the next problem you would like me to cover. See you in the next video.